Our goal is to check the convergence and divergence of the following series. The summation of n divided by ln of n to power n starts from 2, goes to infinity. Remember the root test. Root test says if the limit of the nth root of the absolute value of a n as n goes to infinity is equal to L, and this L is less than 1, our series is absolutely convergent, so it is a convergent series. However, if L is more than 1, you get a divergent series. And if L is equal to 1, the test is inconclusive. It means that the test doesn't work. We have to use a different technique, different method. What is our AN here? Our AN is equal to n over ln of n raised to power n. So let us find the limit of the nth root of n over ln of n to power n when n goes to infinity. But here, you can write this algebraically and see that you have the limit of n divided by ln of n to power n all raised to 1 over n. And you can cancel out n divided by n. And then take the limit as n goes to infinity. So you have the limit of n divided by ln of n as n goes to infinity. Direct substitution gives you infinity over infinity, which is indeterminate form. You can apply L'Hopital's rule. Which says if you have f divided by g and take the limit as your n or x goes to a, it's infinity over infinity or 0 over 0. This limit of f over g and goes to a is the same as the limit of the first derivative. You can also use the second derivative. If the first derivative doesn't work, give you another indeterminate form of the form 0 over 0 or infinity over infinity. This is g prime of n. N goes to a. So we are applying L'Hopital's rule here. This guy is equal to the limit of the derivative of n divided by the derivative of ln of n as n goes to infinity. The derivative of n is 1. The derivative of ln of n is 1 over n as n goes to infinity. Well, here we have an interesting case, interesting scenario. Why is that? Because this guy can be simplified into the limit of n as n goes to infinity. So it goes to infinity, right? So what does it tell us? Using the root test, we end up having a divergent series. Using the root test, the series of n divided by, and let me write down the whole thing, okay, to power n, ln of n to power n starts from 2 to infinity is a divergent series. Let us recap what we did. So we are checking the convergence and divergence of the following series. We have the summation of n divided by ln of n to power n. We're going to apply root test because of this exponent n. So this is our very first attempt. If this attempt doesn't work, it means that if L is equal to 1, you get inconclusive test. It means that we have to switch to something else. For now, because of power n, I'm going to use the root test. I'm going to find the limit of the absolute value of n divided by ln of n to power n and take the nth root of it. Well, I can cancel out the nth root of the exponent n. These two are canceling out. So you're left with the limit of n divided by ln of n. As n goes to infinity, you have infinity over infinity, which is indeterminate form. When it is indeterminate form, you can apply L'Hopital's rule, which says the limit of f of n divided by g of n as n goes to a. If it's infinity over infinity or 0 over 0, you can basically take the derivative of the numerator, take the derivative of the denominator, and find that limit instead. So the derivative of n is 1, the derivative of ln of n is 1 over n. If you flip this and write it on the numerator, the limit goes to infinity. What's the meaning of that? It means that by root test, the series is a divergent series.